So here is our second video of chapter number 5, where we will be seeing about the point of discontinuity. See here, the definition is given in your books also on page number 148. Suppose f is a real function on a subset of the real numbers and let c be a point in the domain of f. Then f is continuous at c if limit x tends to c, fx is equal to fc. This is the basic definition of a function to be continuous. It's given in your book. Again, I am telling you, it is on page number 148. If f is not continuous, now I am talking about the point of discontinuity. How we will be saying, if the function is continuous at point C, now if it is not there, if f is not continuous at x is equal to c, then we can say that this function f is discontinuous at c, and this c is called a point of discontinuity of function c. Many times question comes, check the point of continuity or find the point of discontinuity of the given function. So here we can find out like this. Let's just see one example over here. Here we have to check the continuity of the function fx is equal to 3x plus 1. This is the given function, and this is had to be checked at x is equal to 1. So the value of c here with c is x is equal to 1. So we have to check the continuity of this function. Let us see. According to the definition only we are going to do this. See here what we have to do. Limit x tends to c, fx is equal to fc. So first point we will be finding f of 1. So we are putting here f of 1 means 3 into 1 plus 1 is equal to 4. The value of f1 is equal to 4. This is the value like we were finding fc. So f1 is 4. Now we will be finding limit. Limit x tends to 1, fx is equal to limit x tends to 1, fx, putting the value of fx over here, 3x plus 1, then putting the value of x is equal to 1. So it becomes 3 into 1 plus 1 is equal to 4. Means these two values are same. Hence we can say that the given function is continuous. So see here how we can write it. Thus limit x tends to 1, fx is equal to 4 is equal to f1. Thus the given function is continuous at x is equal to 1. This does not mean that every time the function will be continuous. Now we will be seeing another example where the function will not be continuous. See here the second question. We have to again check the continuity of this given function. Fx is equal to given 2x plus 3 if x is not equal to 2. And is equal to 6 if x is equal to 2. Two conditions are given. When x is equal to 2, then the value of this function is 6. If not equal to 2 means if it is less than 2 or greater than 2, the function is 2x plus 3. So let us see. Again the first step, finding the value of f2. f2 is already given, it is 6. This is the value of 6. Now we will find the limit. Limit x tends to 2 fx is equal to limit x tends to 2, putting the value of this function 2x plus 3 we had substituted over here. Now applying the limit x tends to 2. So this becomes 2 into 2 plus 3 is equal to 7. So this was 6 and this is coming as 7. So these two things are not equal. So limit x tends to 2, fx is not equal to f2. Therefore this function is not a continuous function at x is equal to 2. So this does not mean that every time the function is coming to be continuous. Let's see one more example. Here we are talking about a modulus function. Check the continuity of the function f defined by fx is equal to mod of x at x is equal to 0. So we are given this function fx is equal to mod x. Already we had studied in class 11th. How to write this modulus function? Fx is equal to x for all positive values and for 0, and minus x for all x less than 0, means for all negative value, means ultimately the value of the function always comes positive. So again we will be finding out for continuity the value of the function fx at x is equal to 0. At x is equal to 0, it is 0, means f0 becomes 0. Now we will be finding out the left hand limit as well as right hand limit. Limit x tends to 0 minus, means what we are going to find out? This, when x is negative side. So limit x tends to 0 minus, so the value of function is minus x. We will be putting it here minus x, and we will be putting the value of 0 over here, so the answer is 0. For right hand limit, limit x tends to 0 plus fx. Now the function will be taking this one, x, positive value. Again it is coming 0. So we can say that the left hand limit is equal to right hand limit is equal to f0. All the three values are coming as 0. Hence we can say that the given function fx is continuous at x is equal to 0. Right? So this is the modulus function which can come in exams also. How we will be proving that the given function, that modulus function, is continuous. So in this way you have to show all the steps. Left hand limit, right hand limit, the original function, how you are going to write this modulus function, this all things. Let's see one more example. Let's see now for quadratic equation. Discuss the continuity of the function f defined by fx is equal to x square plus 3x minus 1. Now since this is a quadratic function, so its domain is all real values. If we just find out the values of x, there will be real values. Always a quadratic function, its domain is always a real number. So domain will be R only, real number. Now we have to check any value out of these real number for which the function will be continuous or not. Let's see a point. We are taking a point C which is belonging to real number and FC. Then we have to find f of f at this point. So at place of x we will be substituting c. So this becomes c square plus 3c minus 1. Now if we apply the limit x tends to c, fx is equal to, again it will be coming as same, because if we substitute here the value of x square plus 3x minus 1 and putting the value of x is equal to c, it will again give us c square plus 3c minus 1. Thus we can say that limit x tends to c, fx is equal to fc. So we can say that the function fx is continuous at x is equal to c. Thus the given function is continuous at every real number. We just took any number, c, any arbitrary number out of this real number, and we had proved that this is the condition for the continuity which is coming to be same. Hence the given function, this quadratic function, is continuous. In the next topic we will be studying about algebra of continuous function. Okay, have a good day.